An HMI, a human machine interface, is the screen an operator uses to understand and operate industrial equipment, pumps, tanks, conveyance, any sort of industrial project or product will typically have a user interface known as an HMI. Today, engineers often build those screens manually from specifications and tags lists. Verkas turns that paperwork into a reviewable starting point in minutes. What I'm doing here is I'm creating a project folder uh, that I'm calling Tank Project Verkas Demo, which we will then use to demo this product. We can import the specification from Word, or it can be typed in manually. To get it from Word, I have it in my downloads folder over here. And we will pick the spec. When we open it, you'll see it populates the specification into the control narrative, and we can analyze it, which is currently powered with GPT 5.6. Verkas is built on a few different AI platforms. I originally was using Kiro, Claude, and Codex, but I was kind of stalled out and I'd let this project sit on the side. During this build week, I supercharged the development using the new 5.6 models from OpenAI. I had an unusable but somewhat built project before this week, and you'll see now through this demo that I have a working prototype all built on these new 5.6 models this past week. Also, the API calls, all of the AI built into this product is currently running off of 5.6. GPT 5.6 reads the engineering specification and identifies the equipment, signals, alarms, and operator needs. Verkas HMI proposes the screen structure, but the engineer reviews it before anything is generated. You can see here the system summary is built out into clickable tiles, areas, equipments, alarms and tags, operation, the modes, what's physically there, the faults, everything that you might need in your project has been brought in. It is here to review, and you can manually add any edits you need and work with this to be regenerated from your feedback right here at the bottom. Next, there's a proposed HMI structure. Based on your spec, it'll propose what should be in the header space, which is standard in most HMI systems, that there's a header with some information. It'll select which pieces of information it thinks that the user should need, though you can override that yourself and check other options. It'll give you a list of screens that it thinks are needed for this user interface in this HMI. It'll show you how they'll flow together on the left. It'll tell you what's in each of them. And again, there's other standard screens that may not be suggested, but as the user, you can override and add them. So in this case, it thinks you need a systems overview, tank fill and drain controls, tank systems alarms, but you could also add trends, settings, event logging, or diagnostics. And then lastly, if that all looks good, you get to come in here and tell it that you approve that framework. You generate the approved screens, and you instantly have a user interface built by AI, reviewed by you, the engineer, that is 95% of what you need for your HMI, built in a mere minutes, as opposed to what typically has been days, weeks, or sometimes on larger systems, even maybe months.